Hello everyone and welcome to our second week learning with functions. Please, if you have not already done so, before you watch this video, watch the Edpuzzle video and answer the questions. So I want you to do that before you do this, or else some of the things that we talk about are not going to make sense. So you'll see that function notation, the Edpuzzle, that is already done if you're watching this video. So for homework, you just have to do the IXL, AL for algebra.q.7, and that will be found as a link in Google Classroom where you found this video. Today we're talking about function notation. If you've watched the video, which you should have if you're still listening to me right now, then you know that function notation is essentially writing a y equals something, 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 except we're replacing the y with f of x or g of x or h of x or anything. In the video, they even mentioned it doesn't have to be of x. It could be s of t. It could be p of t, things like that. Don't worry about this right now. We're going to be doing everything of x, okay? And so we can say our function g varies by x, or okay? So before we begin, I just want to look at this right here, and we're going to write this in what's called function form. Well, now that you know a little bit about function notation, you know that that f of x or g of x or h of x is replacing the y. But you've seen this entire time that the y has been by itself. So in order to write something in function notation, we first must write it in function form, which is solving for y. Okay? So if we have 2x plus y equals 1, this is not in function form until the y is alone. So in order to do that, we're going to get rid of this 2x here. How are we going to do that? We are going to do that. I don't want this to look like division. We're going to do that by subtracting 2x from both sides. And now we have y equals, we're going to write the x first. So negative 2x, and this is a positive 1, plus 1. This is function form. So function form is y equals negative 2x plus 1. Function notation would be f of x equals negative 2x plus 1. That's function notation. Okay, so now you know the difference between those. Whoops, I forgot an Asian. Function notation. Okay. All right, so let's get started on reviewing and talking about what you learned in that video. So, when we have something written in function notation, we would read this as f of x equals negative 3x plus 8. So they now say to find f of x when x equals 5. They're asking you to replace the x every time you see it with the number 5. So if we had f of x equals negative 3x plus 8, we're going to replace the x with 5. But to be helpful, we're going to replace this x with 5 also. So we're going to write this as f of 5 equals negative 3 times 5 plus 8. F of 5 equals negative 15 plus 8. So f of 5 equals negative 7. And that's our answer. And what we're actually finding here is an ordered pair. The x is 5, and remember, f of x represents y, so that means this whole thing, f of 5, is just a replacement for y, so this is the ordered pair 5, negative 7. Then they ask you to replace f of x with negative 22. Now you notice we're not replacing the x here, we are replacing the f of x. Essentially, they're asking you to replace the y. So here, now instead of replacing the x with 22, we're going to replace the f of x with 22. So here we have, so it was f of x equals negative 3x plus 8. Negative 3x plus 8. And they're asking us to replace the whole f of x with negative 3. So we're going to actually replace the f of that, or I'm sorry, with negative 22. So we're going to replace this whole thing with negative 22. Now, what do we notice about this? Well, now I have an algebraic equation where I'm solving for x. So I subtract 8 from both sides. I get negative 30 equals negative 3x. I divide by negative 3, I divide by negative 3, and I get 10 equals x. When I replace the whole f of x with negative 22, I find that x equals 10. We can write that as f of 10 equals negative 22. Okay? All right. So now we can practice a couple of different times, but before we do, I just want to go through and ask you, are we replacing the x or are we replacing the whole function notation, okay? The g of x in this case, okay? So number one, they say find g of x when x equals 2. So are we finding the x or are we finding the g of x? We are going to replace the x with 2 to find the g of x. Number two, are we replacing the x or replacing the g of x? Here we are replacing the x because this would have said g of x. Instead, the x says negative 10. And finally here, number three, they're asking, are we replacing the x or the g of x? We are replacing the g of x here and finding the x. Okay? Do you hear the difference between that? We're finding here. We're given x and finding g of x. Here, we're given x and finding g of x. Here, we're given g of x and finding x. Okay, so for number one, we're going to write this as g of 2 equals 4 times 2 minus 5. G of 2 equals 8 minus 5. G of 2 equals 3. Number two, we're saying g of negative 10 equals 4 times negative 10 minus 5. G of negative 10 equals negative 40 minus 5. G of negative 10 equals negative 45. And finally, number three, we are actually replacing the whole g of x with 19. So this is going to be 19 equals 4x minus 5. I add 5, I add 5, I get 24 equals 4x. So x equals 6. So I can write that as g of 6 equals 19. And what we've found are 3 ordered pairs. This is the ordered pair 2, 3. This is the ordered pair negative 10, negative 45. And this is the ordered pair 6, 19. Remember how we talked last week about if we have an equation, we can just plug in x values and find y values to get a whole bunch of different ordered pairs to graph it? That's the same thing we can do here, just as a function. Numbers 11, 12, and 13, we're doing roughly the same thing, except in this case, we have an f of x and we have a g of x. Doesn't make a difference. It just matters to what question we're talking about what. So here, actually, I'm going to use a different color here, because number 11, we're talking about the f of x. Number 12, we're talking about the g of x. Number 13, we are talking again about the f of x. Okay? So number 11, we are replacing the x, not the f of x. So we write this as f of negative 1 equals negative 3 times negative 1 plus 1. F of negative 1 equals 4. Okay? Number 12, we are replacing the x. So we have g of 5 equals 10 times 5 minus 4. And then we have g of 5 equals 46. And number 13, we're replacing the whole f of x here. So we're going to have negative 17 equals negative 3x plus 1. When we go to solve for x, we get negative 18 equals negative 3x. And then we get 6 equals x, which means f of 6 equals negative 17. Okay? All right, the last one, the last set here, again, we have f of x and g of x. We're talking about the same functions, okay, just new problems. Now here, we're talking about the g of x. So here, I'm going to do, okay, so we're talking about the g of x here, okay. So they want the whole g of x replaced with the number 31. So we do 31 equals 10x minus 4. Which is 35 equals 10x, x equals 3.5, or we can write that as g of 3.5 equals 31. Number 15, we're talking about the f of x, and we're just replacing the x value here, so we write f of negative 20 equals negative 3 times negative 20. Plus 1, f of negative 20 equals 61. Okay, and then finally, for number 16, we're going to replace the x in the f of x with 4, and then we're going to replace the g, the x in the g of x with negative 3. So when I do that, f of 4 winds up being negative 11. When I plug 4 into here, negative 3 times 4 is negative 12, plus 1 is negative 11. Then when I plug in negative 3 as the x for the g, I wind up getting negative 34. So g of negative 3 equals negative 34, because when I plug this in here, 10 times negative 3 is negative 30, minus 4 is negative 34. And they're saying they want you to do whatever you got for here plus what you got for here. So negative 11 plus negative 34, and that equals negative 45 as your answer. Okay? All right. Go on and give that IXL a shot. We're looking for a SMART score of 85 as always. All right. If you have any questions, email me, and I'll see you later.